All right. Yeah, welcome to our final presentation for AI for online education. I'm Ted. I'm joined with by Harshith. So let's just jump right into it. So this online education has been kind of a increasing phenomenon in demand over the last few years. And with that, we have intelligent tutoring systems makes use of a lot of the student information to enhance their systems to improve student learning outcomes. That's just saying that we have a lot of systems out there that promotes a lot of online education to personalize learning. So what this really is that for a specific course or something, these systems will have a specific teaching strategy that is tailored towards the student. And these tailored instruction goes through interface, and all of that data is collected and fed back to the student model. So they kind of want to understand the student knowledge state. So how well is a student performing if they're like an A, B, C range kind of student, and what kind of help they would need. We're fortunate enough to partner with an ITS platform called CK12. So they were a platform launched in 2007 by the CK12 Foundation. And our mentors, Tom and Robin, have an active collaborations with them. So the idea is that you can select hints based off the student's past log and data. So you would have kind of a data-driven approach in which you essentially A/B test certain kind of human curated hints and questions to see how effective it is for students. So the primary data sets were provided from them, and from there we use biology and physical science as our data set. So the problem description is framed as so that since this is a data-driven approach, most of the research that is done in the past is just essentially having a ground truth of, through these systems, how are students essentially becoming more equipped or better or at answering these questions. And so there's essentially an accuracy score from all these students that are participating in it. And then the idea is that all of this is just essentially statistics, right? No one's actually looking at the actual textual information in there that the students are looking at. So we want to essentially utilize the textual information. So another problem is that students could potentially be harmed and exposed to suboptimal hints. So the reasons that that is a problem is that these are highly confidential data and hard to get access to. Why nobody has looked at essentially frame the problem like we did. And the answer to that is that we do have access to a lot of this information, so we are well equipped to tackle this problem. So our proposed situation is that, like I mentioned earlier, we look at the textual information. So that is, well, be it questions, answer, hints, lesson plans, anything that is relevant to the student that they have access to. And from there, we essentially get also the student log information, which is kind of like what are the question types that they are exposed to, like question types, assistant types. We all feed that into a sentence embedding using both OpenAI and other kind of word embeddings. And then from there, we are essentially selecting the best hint to provide to the student. So our hypothesis is that there is rich information in the textual information. So some of the metrics that we are looking at is that from the embedding sides, we're using Ada. We also use GPT 3.5 Turbo and GPT 4 to ask which hint in a pairwise comparison is better. And for our model that we use, we look at the accuracy, how well we were able to predict between a pairwise classification setting and then the AUC score under ROC, as well as the binary cross entropy loss. So some of our major features are, like I mentioned, sentence embeddings, Ada embeddings. Previously in the past, we wanted to compare different kind of embeddings like DaVinci, BERT embeddings, realistically to get kind of a baseline of what kind of embeddings we want to use. And ideally, the embeddings will find like a kind of a strict correlation between questions and hints. So our major feature for our other side is, for our machine learning side, is the classification model. So what we want to do is we want to predict the reattempt score. The reattempt score is essentially what we use to dictate which of these classifications or which of these assistants is better. And through that, we do a pairwise comparisons of the assistants. And our intended users is pretty broad. We obviously want to impact those of the students, our collaborators, CK12, and the global scientific community as well. So some of the system functionalities of this is that the online tutoring system goals is to improve the hint selection using text, and we obviously want to enhance learning outcomes for students. Some developmental step is what we see from CK12 is kind of raw information, both in the form of log data as well as raw text from just like the lesson plans. So we want to create a sentence embedding using these data, and then we select the best hint corresponding to the questions with the classification model. And then through there, we want to explore the comparison between our model and other large language models, mainly GPT, and combine the data-driven features with sentence embeddings to classify them. Some of our non-functional requirements are the usability of it. We want to deploy a hint selection and ability to deploy that. And then compatibility is that we want to improve student retention, learning experience, support CK12, and to be able to implement this at scale. Accessibility is that it's going to be through the CK12 platform. It's reliable and scalable to millions of students. And security is ensure trustworthiness and consistent results, as well as confidentiality of the student data and the performance, the speed of prediction as a secondary function. And we want to achieve as a high of an accuracy score as possible. And I turn it over to Harshith.
Thanks, Ted. So basically, in order to achieve this, we had certain resources that we made use of. We made use of the GPU clusters that Tom had access to. And then we were thankful enough to the $10,000 Microsoft Research grant that we got, which we used to access GPT 3.5, GPT 4, and that was pretty useful. Some of the design considerations was that in the beginning, we wanted to see what the current state of the art is, what the baseline was in trying to figure out. So basically, our major thing is that a student answers a question, and then if he gets it wrong, he or she gets it wrong, they provided a hint. And then we have ground truth data for that, which is the second attempt correctness rate. So now we evaluate the effectiveness of each hint based on that. Now, the baseline here, we found that the most common type of hint, there are three types of hints: a hint, assistance actions, I'd like to call them, hint, vocabulary, and paragraph. So we found that paragraph was the most. So the best performance we got was always picking a paragraph, and we use that as our baseline. So we kind of built the questions text, assistance text, and the answers text, and then pre-processed it, and we conformed it to our classifier model. So some of the assumptions here are just that we wanted it in a certain format, and then we assumed that we had sufficient text data in order to achieve this goal. And we went ahead with using ADA features because they were better than DaVinci. And we also got access to GPT log probabilities, which we added as another feature to our classifier. And for the neural network training, in order to find our best hyperparameters, we kind of ended up using Optuner, which gave us I think, to use 693 neurons in our neural network, and that did a good ablation, and then we were able to get good results with that. So this is just an architecture of how our model looks like. So if you look at it there, you have the student log data, which is basically raw data that we have. We conform it to the question text, and then the assistance text A, assistance text B, and then we also have we segregate the correct answer to the incorrect answer. Now, for example, there are two types of questions here. We have fill in the blanks and multiple choice. So when you have multiple choice, you have, let's say, 4 options. The other 3 go into the incorrect answer text field. If there is no incorrect answer field, that's just empty. And then we also have the question type, which actually improved our performance a little bit, which was like the hint, paragraph, or the vocabulary. There's also no assistance, but we don't consider that here so far. And then we have the GPT log probabilities, which basically you're prompting GPT, asking it which is better. And then out of that, you're given a probability as to which one is better than the other. You get it as log probabilities, you get the exponent of that, you just get it as a 0 and 1 value between the 2 hints. And then you feed it into the input layer, and then you just have 2 hidden layers, and then finally a bunch of activations, and then you kind of find out the probability of which hint is better. Now, the LLM part of this, how we made use of GPT is that we took the text that we had, and then we created a prompt with it, which we'll show you later, and then prompted GPT 3.5 Turbo or 4 to ask it which is better. So basically the prompt would go like, hey, you are a dash teacher, and then you're given 2 hints, which one is the better to help answer the question better. Right, and this is a diagram of how our data set looks like, which I already spoke about. And this is sort of the entire pipeline of how it looks like and how is the model implemented. We have the embeddings, and then we have the ranking metrics such as accuracy, loss, and AUC. And then also finally we rank the hints, and then we hope we actually finish submitting our paper to AAAI, and then we're hoping to talk to CK12 now to incorporate it. And this is just an activity diagram. A student kind of answers a question. If they get an incorrect answer, we want to use our model to give the next best hint. And then after that, you go to the next question and so on. So this is how the CK12's interface looks like. You have a question, pick one out of the 4 options. And then if you get a wrong answer, your hint is suggested. And then basically here is where we want to incorporate our machine learning model. Previously, Robin had submitted something which was being used by thousands of students every week, and we intend to do that later. Now, the design models here, we made use of 2 course data, biology and physical science. I think in the midterm, we only had 1 course data, and then we extended it to another one. And then we also performed a feature analysis to figure out which one of the features is best and how that affects performance. And we did certain ablations, and we made use of the probabilities that we got from GPT-3 and GPT-4. Not GPT-4, because GPT-4 does not provide probabilities, but GPT-3. And this is just more of how our data looks like. It's kind of like, this is a summary of whatever I spoke about right now. The testing design here looks like we have the accuracy, and then we have the AUC, and then also the binary cross entropy loss, which we report. And we use the GPUs that we got, and then also the grant, and then we want to incorporate this into CK12 data. Some of the risks here is that since we are working with personally identifiable information, we want to be careful with what types of hints we select. They must be adhering to certain constraints. That's some of the risks that we might have in terms of business risks. And some of the project risks that we had was the classification was largely unexplored, but we were able to get good results with that. And we were able to integrate the log probabilities as well. And these are some of the tools that we use, such as like the Azure OpenAI API, the PyTorch library, and Optuna for fine-tuning. And this was our task summary that we had during the midterm, and we were able to follow this. We submitted to the AAAI workshop, and then we finalized the models, and then we are intending to submit later on to an extension of this to ICML coming in the next year. And this is a snippet of how our process data looks like. We if you can see here, you have the question ID, and then you have your assistance ID, then you have your question text. If there's a blank in it, that's kind of like a fill in the blanks question. And then we have the assistance text. If you see the NaN values there, which means that no assistance, that's also a certain type of assistance action. And then you have your second attempt average, which is basically an average of how well they did after this hint was provided. It's like a 1 or 0 if you got it right after the hint or not. And number of samples is the amount of data that we had for each particular row that we have here. And this was the prompt that we made use of. Basically, you are a high school teacher / teacher. So that would be, a subject name would be here biology or physical science. And then a student was asked a practice question but answered incorrectly. Which one of the following 2 hints is more likely to help the student answer correctly? And then we provide it in a structured format, and then we expect the decision to be hint A or hint B. Right, now I'll hand it over to Tech to talk about some of the results here.
Yeah, so for these results, these are also kind of paired with the log probabilities, like the prompt that Harshith was mentioned. These were the outputs from there. So as you can see there, we have essentially question IDs and assistance IDs, and they will map towards specific textual information. And from here, we're able to query GPT for it to make a decision on which of these hints were actually better. So going further into our isolation studies, future isolation studies of our classifier, we wanted to see the baseline. The baseline, what we define as the baseline, is essentially the model is only getting fed textual information from just the question assistance. Intuitively, you would think that, you know, when you're a student answering a question, all you have access to are those 2 textual texts. So the question that you're being asked, and maybe like a hint or something, try to help you push you towards the right direction. And with that, we wanted to also add the correct answer. So the correct answer is the answer that is the answer to the question, and also the incorrect answers. The incorrect answers are student submitted answers. The assistant type is what Harshith was talking about. We have 4 assistant types in which there are paragraphs, vocab, hint, and no assistance. But we don't actually consider no assistance in this. And then the question type is essentially multiple choice, fill in the blanks, etc. And the GPT 3.5 prediction is the slide that I showed you before. Essentially, which prediction did it pick? And so as you can see, the accuracy here is what we wanted to do with this feature isolation is to see that what feature within our model was actually giving was actually holding like the most weight for our model, right? Like which is actually helping it decide correctly. And so through this feature study, you can see that it's mostly just the baseline, as in the question assistance embeddings is giving it the best decision. And so these are our main pairwise classification methods. So we wanted to compare it to a random baseline and always paragraph. The reason we have a method for always paragraph here is that we, through our analysis, the paragraph is actually the assistant type that gets selected the most. So if you just randomly select paragraph, it actually will give you the highest accuracy out of all the other kind of assistant types. And here we also compare it to the GPT 3.5 and 4 predictions. So as you can see that with our pairwise classifiers, the baseline, it's actually able to do classify more accurately than all the previous GPT iterations, and as well as the baseline. So not only do we want to we also want to understand where our model is actually doing well. As you have taken classes before, there are questions that are harder, and then there are questions that are easier. So here we have like kind of the accuracy and effect delta. So what the effect delta decile is essentially what is the difference between the reattempt scores or the ground truth scores that we are looking at, these pairwise questions. So obviously, if you have a question that, has like nobody or 10% of the class or something answers it correctly, that will probably be a more difficult question versus a question that 90% of the class answers well. So as you can see in our pairwise classification, we're actually able to predict really well when it comes to just questions that everyone else, what were questions, comparison between assistant text between ones that are harder to predict versus easier to predict here. And this is just essentially the trend we're saying. As it kind of gets more similar, it's obviously gets harder to predict. If there's, the ground truth is like 50-50, our model is also essentially predicting like kind of just like a coin flip. And so that leads to our conclusion. So what is the impact and contributions of this? Well, our model allows ITS systems to pre-screen their hints that are generated through either human creation, or now in the age of large language models, there's a bunch of, you could probably just generate a hint for a specific question. So this allows for better curation, which will hopefully translate to improved performances by students. In doing so, most of the past studies that's been done on this has been a data-driven approach, in the sense that you have to do kind of an A/B comparison. Like what if you're having a new hint or a new assistant, right? You would have to essentially plug this into your system, see how it does with the students, and if it's a good viable candidate. So this allows for us to efficiently sample to reduce the suboptimal exposure of assistances to students as well. So there's still much to be done with this research project. We do want to improve our model by incorporating an ensemble model to account for prior data-driven models and methods. And additionally, we want to use our model to enhance overall learning outcome, because that's the goal of these ITS systems or any kind of educational platform. It's to essentially improve overall learning outcome of that student. We want them to actually understand the material better. So something that we've been working on parallel to this is also sequential question effects. We want to see that so like in a lesson, when someone's sitting down and doing a lesson, students doing it, they're given sequential questions afterwards to answer. And if they get a particular question wrong in that period, they're given an assistance. Well, how does that assistance actually help downstream questions. And you can look at this from, kind of a local level and then extrapolate it out to more of a global level, right? Eventually, we want to see how performance eventually this course will affect life outcomes maybe, right? But for now, it's just mostly, performance in this specific time period in this course, how will it affect the learning outcome of someone finishing the rest of this course. And so, yeah, we would like to thank our mentors, both Tom and Robin. They've been a great support for us and a great way to brainstorm our ideas. And they've been really helpful throughout this entire year's process. And thank you guys for listening and for taking the questions.
So I'm going to jump right in with my questions. We've got plenty of time, and then definitely want to hear from the other instructors who are here. It wasn't clear from your initial diagram whether the student model is a per student model or whether it's a global model that you're training for everybody in the class.
It's global right now.
Okay. And then let's see. So I think what's not quite clear in the presentation is you're doing classification, but since you framed this as selecting between one of two assistance types, really it's sort of like ranking by classification. So explain to me sort of what's going on algorithmically there. I'm giving you an input
Right.
that has two things.
Mm-hmm.
And then you're talking about a classifier. So how are you using a classifier to pick between the two assistance options?
Yeah, so essentially it's based off of like the features that we're inputting into it. So for like a set of features that we give the model, it's going to have the embeddings for the assistance, the two comparisons of the assistance that we're looking at, and all our other additional features. So essentially it's the last layer of it is sigmoid layer, which is predicting essentially what's the probability of me choosing assistance one, and that's the indicator. So if it's 0 or close to 0 or anything less than 50%, it will pick assistance one.
So it makes sense to think of it as a classifier, but it's not a binary classifier. You're basically getting the likelihood out.
Yes.
Yeah,
That to make a decision between the two.
Right.
So one of the things that could have been improved in the presentation is telling us much earlier what courses they were, what the intended students are. I still don't know sort of what the educational level is of the students. It also was very far into the presentation before I saw examples of the instruction. So I think you want to be careful about that. When you're presenting this to audiences that you haven't heard from you before, it's probably better to do something earlier on. I think there's a sort of the looming scientific concern that I have is you only looked at two assistance options, and then there's potential loss of generality there, and you even called that out in your list of product risks, which I think is good. But it's not really clear how realistic it is to transfer this to the real world use case. So is everything that CK12 is doing based on two kinds of assistance, or are you guys going to have to figure out how to generalize this to some small n numbers of kinds of assistance?
So each question has, let's say, 4 to 6 assistance actions, right? So we do it 2 at a time. Certain heuristic would be to pick which one wins the most out of those pairwise comparisons.
Okay.
So that way, I think, could work for CK12.
So you're going to implement a bubble sort using the likelihoods on pairwise.
In our previous iteration of this, we did it through a regression task in which we're essentially trying to predict the ground truth, like the accuracy of it. But that actually became a harder task, and we were actually able to beat the baseline. Okay. So the idea is like, what Harshit said, you could do a ranking method in which you do all possible combination, and whichever one wins the most, you select that as the best one. Okay. But there's a bunch, there's other ideas out there as well.
Okay.
To do.
Yeah, so definitely, providing that technical detail presentation, like the effective employers, and so on. So can we go to the feature isolation slide? I did not understand what was going on here. All the accuracies seem more or less equivalent. Yeah, so across the 3 metrics that you have there. So what was the point of this slide?
The point of this slide was that we wanted to do essentially isolation study in which we wanted to see which feature actually contributed the most to our decision. And so one way you can do this is through feature isolation or feature ablation, like you start not including certain features. We just did it the other way. We just only put in that feature for it. And through this, we wanted just to say that, you know, we wanted to make our baseline just be the question assistance, because intuitively, those are the things that a student is getting, and they're going to infer some information from that. So with the correct answers is saying that in addition to the question and assistance embeddings, we also gave it the correct answers. And what we're saying with this study is that most of the log data or these other types of information don't actually affect the model's ability to predict accurately, like classify accurately.
Okay, so this is everything minus the text.
Yeah.
Okay,
Yeah.
so you could have made that point a lot
Right. Yeah.
clearer, I think, when you were showing the slide. So at the end, it was very interesting to think about sequential question effects. And that questions aren't independent, and that order matters and prior assistance matters. But, you know, that also implies that you guys made an independence assumption with this work, right? So how much of the results that you're sort of presenting now are clean with respect to this assumption, or do you think that there is, you know, some dependence going on there that might actually be skewing the results that you have so far? Because what I take from this is that you're basically looking to see if, you know, the next retry is better or not. So I guess that's something that you can sort of think of as sort of a limited thing. But maybe you need to look downstream at whether or not somebody is more successful at the next question based on the fact that you gave them assistance.
Yeah, we already
what you're saying.
Yeah, we already started that ANOVA test, and I think in one of our previous presentations we spoke about that, but we weren't able to finish that aspect of it by the paper deadline. So we wanted to focus on the pairwise classifier for now, but that is also in the works, and that's going to be done soon as well.
Okay, and then my last point is on this slide, you didn't say why you wanted to improve the model by going for an ensemble. I mean, I understand why you need to consider the sequential effects, but were there specific error categories or performance gaps that motivate this idea of an ensemble, or you just want to try it to see if that?
No, I think so. For the feature isolation, we saw that just giving it, you know, just log data into like it as a feature doesn't actually improve it. So there has to be another way. Like intuitively, we would think that these log information that you would have of essentially like what kind of question type, you know, the question is would actually help the model predict it more. So there could be essentially some kind of meta learner we get from this that we feed in through two models, kind of the information, instead of just maybe it's just because that, you know, the neural model is essentially downweighting those features because they really aren't significant and we want to upregulate that.
Okay.
Yeah.
So you're not convinced that they can be summarily?
Yeah.
Okay.
Not yet.
Anybody else have a question for the team?
So I had a lot of questions, but I'm gonna have to limit myself to one because I have to go interview somebody. But I still don't get what your ground truth is.
So the ground truth is that let's say I'm a student, I answer a question and I get it wrong, and I'm given hint A and hint B. If I answer it correctly using hint A, the ground truth increases by 1. If I answer it incorrectly, the ground truth increases by 0. And if you look at the number of samples here, let me pull up that slide.
So are you just saying that you looked at logs and for every question you where students got it wrong, you looked at the different times that they might have gotten one hint or another hint, and you looked at which one was a better hint?
Yes.
Or in the sense that they were able to get the answer right. On the other hand, a good hint then might be one that's really close to the bottom out hint, which is like essentially giving them the answer.
Yeah, we did do that analysis. We did do that analysis, like, but then some of them, like, for example, fill in the blanks, right? Dash is the amount of species ecosystem. I think the answer for that was biodiversity. So the way the hints, some of the hints were that they actually mentioned the answer with them also. And then some of them gave a wrong explanation for that particular term. So that was not useful. It's like saying it would mention biodiversity, but give it a wrong definition and things like that. So there was like a little bit of false negatives and things like that there.
And then the hints themselves that must be the ones that they were already using in their system, right? So then I guess, where did those hints come from initially?
I think CK12 sort of created.
They're like human curated. Yeah. So like from experts.
Yep. So you're taking the text and then you're sort of like predicting which one is better. Yeah.
Most of the techniques that you so it doesn't seem like it's a big win.
We were able to get like 10% improvement, I think, over the baseline.
I didn't see that in your slide.
Because
It
if you
was from just the always paragraph baseline. If you look at the PYC plus features, it is like a 7%, I guess, increase, or 6 to 7% increase. We usually just always want to compare it to the always paragraph one, because that's the assistance type that essentially, if you pick that, it will give you like the highest accuracy from all the assistances, all the assistant types.
Yeah. I think that there are lots of things about how this is framed that to an intelligent tutoring audience, they would be like, it really feels like this work was done in a vacuum in some sense. So I think that, yeah, I think a lot of things could have been justified.
Yeah, so basically, how I would look at it is that, so when we looked at a particular question and then had 2 hints, us as humans, when we tried to figure out which hint is better, it took us like 5 to 10 minutes. It wasn't that easy because like some of these hints, like I could give you an example later. So like some of these hints were like sort of, both of them were very close and we couldn't figure out which one was better. So us as humans, for that also, it was kind of hard. So that's why I count the 7% as a win, because even for us as humans to figure that out, it took us a while. So it wasn't that easy. And to ask like a machine learning model to do that, that's also not very easy. So I believe that the 7% improvement that we got was kind of like pretty high for that.
Yeah, I think that you should look at a lot, like the literature on like educational data mining and see, what other people have already done. Because again, I just feel like you made a lot of claims about what nobody's done, which are just not true. I think that if it was work done by people who know what has been done and how it's been evaluated, they would have set up things very differently. And so I wonder if that's
There's been a lot of like textual, like not just like educational data mining, like it's kind of like student log data, but we were just essentially looking at more of like the textual information.
So you guys were given an experimental condition. You didn't really examine how fundamentally solid that experimental condition was versus the literature and educational data mining. And of course, you're making an assumption that these guys are collaborating, know what they're doing, set this up. And I think what Carolyn is pointing out is everything in there is subject to further examination because it's a practical system. And I think what you guys did was show that there are practical techniques that can be used to maybe help them one decision point in their data flow. But I don't think you can make general claims about the utility of this in all educational contexts, because there's essentially one specific experimental condition. You didn't do any ablation studies when you tried a different approach, nor did you think about all the other systems that have tried to do this where there are in other ways of hints, kinds of hints. So I think, this is an interesting, piece of incremental research, but it's not sort of like something that, sort of on the way to PhD thesis, I guess I would say.
Yeah.
So I think this has also been, I think, traditionally a tension between people that want to make practical gains with machine learning versus people that really want to understand the nature of online education at the level of what the educational model is. And I getting from Carolyn, some of that traditional concern. So I think it would be great to actually follow up with her.
Yeah.
Get a list of what she thinks of as maybe some of the more important studies for you guys to read about. Because even if you've already submitted your paper, I think it would be great when you present this at a conference, as part of the future work, you should be talking about examining this thing. Now, CK12 just wants to make progress on what they're doing, but it's also part of your responsibility to let them understand, how what they're doing does relate to this, larger enterprise. And I think, you know, we want to go beyond just, you know, using machine learning as the hammer to do something, and to also think about better ways of actually setting the problem up so that machine learning can do an even better job. All right, thanks, guys. Great job.
Thanks.
All right, Plant D, you're up next.
Professor, I think Tom was also on the meeting. I did not mention that.
Hey, Tom, do you have any questions? We got a couple minutes.
I don't think there's
You're
sound.
muted.
I
you're
don't
on
think
mute.
there's sound. Yeah, I think it's Tom's on mute. Yeah.
I was on mute, sorry. No, I'm good. I know you guys have a tight agenda. We've discussed this many
I
times.
think it's too soft, Tom. I think it's okay. I don't know why
Okay.
it's not that. Yeah.
Okay. Okay.
Thanks. See you guys.
Yeah.
Thanks, guys. And Miss Robin.
Thanks.